Front radar, intelligent cruise control or ICC sensors, are part of the safety shield systems. Keep in mind the ICC or intelligent cruise control sensor is mounted behind the front bumper or grille and detects vehicles ahead by transmitting millimeter waves. Now this sensor detects these waves reflected back from the vehicle or vehicles ahead and calculates a distance and a relative speed, and then the ICC or intelligent cruise control sensor transmits this data back to the ADAS control unit, which we just spoke about, via the ITS communication. In this example, you will see that the ICC or intelligent cruise control sensor is located on the vertical hood support. Now, there are many collision repair situations that can cause the intelligent cruise control or ICC to not calibrate properly. Some of these might include using an aftermarket bumper reinforcement, a damaged vertical hood support, an aftermarket vertical hood support, bumper covers that may be aftermarket or remanufactured, maybe the mill thickness on a bumper cover if it's been repaired with body filler or excessive paint buildup, or lastly, the front unibody could be misaligned. Remember, that front radar has a tolerance. Jake, what's the tolerance usually on one of those front radar systems?
Well, it can vary between models. We've seen some Infinities go up to plus or minus 4 degrees, but typically the one that we see is plus or minus 3 degrees. So that when you're going through console and the tech info piece, you want to validate in data monitor or work support, what are the values? So if you see something at 6 degrees or 8 degrees or 10 degrees, then you realize that vehicle is out of tolerance and you could have damage, or you could have one of the bullet points shown actually affected.
Remember, write this down. You cannot count on pre-scanning a vehicle and if there's no DTC saying it's thumbs up. You must check the values of the ICC or Intelligent Control Unit. Remember, not all vehicles are going to have the same tolerance. While we're telling you that the average tolerance is usually going to be plus or minus degrees, it needs to be researched on each and every vehicle.
So Mike, we had an interesting one pop up in Dallas not too long ago. I was working side by side with one of our ADAS calibration technicians, and remember, as you start to calibrate vehicles in your facility, you're also going to calibrate vehicles from other facilities in your market, and that can be other collision repair shops, rental fleets, glass companies. So you're going to see a variety of repair work, right? And some of it good, some of it bad,
yes.
Right? So in this case, we brought this vehicle in, and I noticed when we were putting on the alignment machine, the radar was actually wiggling around on the bumper support. So kind of scary. It shouldn't be wiggling around at all. So as you can see in the pictures, we're seeing damage to the pedestrian brackets in the top left corner up there. I'm also seeing that the bracket that is mounted on the rebar had been held in place by license plate brackets, like license plate push pins.
Oh my gosh.
And so that's definitely a problem. You can see they were trying to make this aftermarket rebar work, and unfortunately we had to tell them, hey, you got to buy a Nissan OEM part, and we have to change that part and try to recalibrate the vehicle again. So these types of, environmental failures and vehicle failures really can make you pull your hair out when you're trying to troubleshoot why the system won't calibrate.
And ladies and gentlemen, that's why it's important to remember that Nissan vehicles and all of their safety shield components and systems are built and designed based on the utilization of genuine Nissan OEM manufactured parts that have been manufactured specifically to the needs of those ADAS components in that specific vehicle. Blind spot warning or BSW precautions. Nissan has a lot of wonderful position statements. And Nissan has a very specific position statement on blind spot warning precautions, specifically in regards to the repair of rear bumper covers. Remember, position statements can be found at collision.nissanusa.com. This position statement says some things such as the side radars, which are responsible for triggering the BSW, sit behind the rear bumper cover at both corners. In a rear-end collision scenario, Nissan does not support any repair, body filler application, or paint work on the rear bumper cover in the general area of the side radars. Nissan service manuals clearly state, and I quote, "Do not attach a sticker, including transparent material, or install an accessory or paint work near the side radar." This is why a damaged bumper cover that has blind spot warning or BSW should always be replaced with a new Nissan genuine part. Jake, what are your thoughts?
Mike, or even some of the early generation Rogues and Altimas had their front radar behind a piece of plastic. So even in a front bumper situation on those early generation radar systems, you could have similar problems that you have on the rear. You know, Nissan's very concerned about the performance of that radar. It doesn't want to alert the customer or alert the driver when there's nothing there.
Remember, if you have a third-party payer that does not want to accept this position statement at face value, remember these position statements are built based on the data that comes directly from TechInfo. So if you need additional information for justification with a third-party payer, don't delay, use TechInfo today. Let's give you an example about what we're talking about using TechInfo to support the actual position statement. You will see in this example in TechInfo on a Nissan Rogue, it says, to keep the blind spot warning system operating properly, be sure to observe the following items. And this is where we will see the information that position statement was built on, that says we can't have any transparent material, we can't repair it with filler material or excessive paint. So remember, while the position statements are good, we can always find the in-depth or the meat of that position statement in TechInfo. Bumper fascia replacements with sonar. Nissan also has another position statement. And keep in mind, for every version of the Nissan position statement, there will always be an Infiniti version as well. You see, some electronic sonar sensors in the front and rear bumper fascia are considered to be part of this Nissan Safety Shield technology. These sensors are engineered to be in very exact positions within the bumper fascia. And if not properly installed, they may not function as originally intended. Now, if they don't function as intended, somebody could get hurt. For this reason, Nissan of North America does not approve of the use of aftermarket, reconditioned, or recycled bumper fascias. In contrast with original genuine Nissan bumper fascias, aftermarket bumper fascias may in some cases, well, you know, the non-OEM fascia or the aftermarket recondition may not come with the pre-drilled holes for the sensors. And this causes the shop technician to have to cut the holes using a rough template. This may lead to instances where the non-OEM bumper cover does not match the original genuine Nissan bumper holes, meaning they're not accurate. In some cases, build specifications are also slightly different on aftermarket bumper fascias than on genuine Nissan fascias. This may cause issues with sensor alignment or performance. In addition, a reconditioned fascia or bumper cover, which was once damaged but has now been repaired, may also be out of specifications to the original undamaged Nissan bumper fascia, which may cause sensor alignment issues. Keep it in mind when they recondition a bumper and they're using excessive primer or any type of filler material, that will cause that bumper to not work properly with that ADAS feature. Remember, you can always reference the service manual section SN for additional information. So Jake, we're talking about these position statements in TechInfo. What are your thoughts?
Well, Mike, you know, sonar sensors and parking sensors have been on vehicles for quite a long time. And a lot of people don't really think they play a role in advanced driver assist, but they absolutely do. And in Nissan's case, the backup collision intervention uses the radar and the sonar sensors to work together and determine if the vehicle is going to apply the brakes. So it's really critical that you focus on getting those sensors in the correct position and using factory parts.
Jake, you and the team of Aztec have done a ton of calibrations and scans, probably more than any of us will ever do. Let me ask you, factually, telling the truth, have you ever seen an ADAS calibration fail because of the utilization of an aftermarket bumper cover or reinforcement?
Yeah, we've absolutely seen that. It creates a lot of troubleshooting problems when you're trying to figure out why it won't calibrate. You replace the bracket, you replace the radar, you look at your values and they seem like they're in spec and the car still fails. And so then you got to start eliminating variables. You know, how hard was it hit? Did it get measured? You know, did they use OEM parts? And you just have to start weeding through all that stuff because, you know, that's one of the things that just creates a lot of headache when you're trying to calibrate these vehicles and calibrate them efficiently.
So here's what we need to remember. That ADAS feature, whether it's a sonar or an intelligent cruise control, a parking sensor, whatever it is designed to operate with specific components that are built to specific specifications like the thickness of the plastic or the thickness of the metal. So that's why, again, we must always use genuine Nissan original parts. The ICC, or Intelligent Cruise Control Sensor, provides data to support the following safety shield systems. First of all, the BSM, or blind spot monitor, the ICC, Intelligent Cruise Control, the DCA, Distance Control Assist, the Predictive Forward Collision Warning, PFCW, or FEB, Forward Emergency Braking, and lastly, the ProPilot Assist. Now, the Intelligent Cruise Control allows the driver to set the following distance between the vehicle and the vehicle ahead using steering wheel controls and the meter display. When activated and conditions are met, the system maintains a set distance automatically using acceleration and braking. Now, if traffic slows down, braking can then be applied until the distance is maintained. If traffic clears up, the system automatically uses acceleration to bring the vehicle back to the set cruising distance or speed. Jake, we see here a control feature. Can you explain to us what some of these features do?
Yeah, so it's important to identify, remember, by trim level, what system your vehicle has, and there will be corresponding buttons that show that. So intelligent cruise control, we can see we can actually change the distance using the button on how sensitive or how close we want our vehicle to follow the vehicle in front of us. We can also see the traditional cruise control buttons that activate intelligent cruise control. And I got to tell you, Mike, as a Nissan owner, I never thought that I would use intelligent cruise control as much as I do, but driving a big truck, it actually helps me save fuel mileage.
Awesome. And remember, if you're not sure, you're not familiar with these features on that specific Nissan or Infiniti, we can always go into Tech Info and review the actual owner's manual for that specific vehicle. So when it comes to intelligent cruise control or ICC, we need to understand what triggers that or makes that system work. Jake, can you explain to us a little bit about what makes that ICC kick in?
Well, remember, the speed is a very critical part of it, right? So between 20 and 90 miles per hour is when you can set intelligent cruise control. I've typically noticed when you're driving on a road and you come up to a school zone, which may be less than 20 miles per hour, it won't engage. So when you're walking customers through test drive scenarios and whether a system works properly or not, it's important to understand the speed.
So again, if we have a customer that comes back and says this isn't functioning the way it used to, first thing we want to do is make sure that they're doing it in the right speed requirements.
Right, and also setting the system using the cruise control settings.
Great insight, Jake. Thanks. Now let's talk a little bit about ICC cancel conditions. Right? Remember how we talked about, and Jake, we talked about if you had dirt or something on a thing or snow or sleet,
yep,
the vehicle would go into fail-safe mode. Is that correct?
Right, yeah.
So there may be some incidences where the intelligent cruise control feature actually just stops or quits working. Is that correct?
Yeah, the one you'll see the most of is the inclement weather, whether it's snow or heavy rain, and that vehicle will fail-safe or cancel it.
So can you give us a little bit of information or insight, Jake, on the ICC cancel conditions?
Yeah, so if you're driving on the interstate and you've got ICC engaged and you encountered a heavy rainstorm, the vehicle will alert you that those systems are currently not available and it will disengage or cancel the system.
So kind of going down this list a little bit, which is on our attendee slide, the following conditions will cancel the intelligent cruise control. Number one, when the cancel switch is pressed. Number two, when the brake pedal is applied. Or if the vehicle head's not detected and your vehicle's traveling below 15 miles an hour. Or if the transmission shift lever is not in the D or manual mode. The parking brake is applied, or when the system judges your vehicle is at a standstill, like a stoplight or a stop sign. Or inclement weather, or ABS, VDC, or TCS intervention. Jake, I know what those mean, but for our attendees, can you explain a little bit about ABS, VDC, or TCS intervention?
Well, certainly. So traction control systems, right? So if the vehicle detects that there's wheel slippage in one or more of the wheels, it's seeing a different mile per hour on one of those wheels and detects that you may be losing control of the vehicle. So it's going to disengage intelligent cruise control in that situation.
Another option that might cause your ICC to cancel is if snow mode is selected, or if we're engaging like in a Nissan Rogue or a Titan, four-wheel drive high or four-wheel drive low. You can also turn the main switch off, and sometimes you may have a system malfunction may occur. Now keep in mind, when the intelligent cruise control is automatically canceled for any reason other than the brake pedal application, a chime will sound. When you're working on the vehicles through this 2-day hands-on course, it's important that you understand what these features are, like is it a chime, is it a buzzer, is it a sound, that lets us know when the system's canceled. You know, Jake, I've had the opportunity to work a ton with you and the team at Aztec, and I've gotten the chance to get dirty and work on lots of cars. And Jake, one of the things I see that keeps coming up in some of these scans we're doing on actual cars that were fixed at other collision repair shops is this DTC C1A12 in C1A16. Now, we talked about C1A16 earlier, but Jake, can you help me understand this thing about radar stain? Because, I got to tell you, Jake, the first time I did a calibration, I got this thing and I thought, hey, there's something wrong. The vehicle's damaged. There's something going on here. Jake, can you help us as attendees here to understand what these DTCs mean?
Yeah, it's really critical in both situations that you follow the DTC logic in TechInfo to identify what condition you're experiencing. So with the stain or blocked issue, could be a, like I said, the dirt, the rain, the snow, those kinds of things. For a block condition,
If you put a reconditioned or repaired bumper cover on it or too much mill thickness,
Right.
would that create this C1A16?
very likely could. You're basically changing the thickness of the plastic, and you're changing what that radar is seeing on the outside world. So you could create a false positive there, and the vehicle doesn't know that you put a bumper like that on it. So it's going to record that type of condition.
I got it. What do you mean by like the laser beams off center? Does that mean like it's not calibrated properly?
Well, that means that your horizontal and vertical axis are out of specification. So you're looking in data monitor or in work support, and you're sitting at negative or plus 6 degrees or 8 degrees or 10 degrees, and the vehicle noticed that, and it says, I'm going to store that fault code that laser is off center. The other thing that we want to show you in the picture here is there were certain versions of this radar that had a manufacturer defect and may be covered under a warranty. So if you look on the screen, I'm going to actually point to the radar arrays here on the front. On the back side, you'll see that this block is actually a little shinier than this block. So on the right hand, that block is actually leaking silicone. In this case, it's not leaking too bad, but on certain vehicles, it actually can leak across the front of this radar array. And when that happens, it creates a radar stained or blocked DTCs that you're unable to rectify. So if that happens, there are Nissan and Infiniti specific tech bulletins that you can give to your customer, and they can take to a Nissan and Infiniti retailer to actually have it handled.
So let's bring this back to a collision repairer's perspective. The reason we're sharing all of these insights with you is that these are probably the two most common DTCs that you will see when it comes to Nissan Infiniti vehicles.
Yeah, so big difference between the two. So if we've got a radar stain block that is current and won't go away, we could have a faulty control module and have to replace it. If it's in history, then it may just be, you can erase it, and that was caused by rain or dirt or snow. The laser beam off center is telling us that laser is off center, and you could have collision forces or damage to the vertical support, the radiator support, whatever it might be, and you need to go and inspect.
Great insights. Remember previously when we talked about for documentation, you may have to have a fuel receipt? You will see in this example from TechInfo on this Infiniti Q60 that it requires that all the tire pressures are set to the specified value before performing the calibration. You see it says we also should empty the vehicle, meaning any personal contents from the owner that are in the trunk we need to remove. It also says, if you look at number 4, that we must fully fill the fuel tank and then check that the coolant and oils are filled up to the correct level. Keep in mind, ladies and gentlemen, these are all not included operations, and they need to be taken into careful consideration when you're determining what your labor charge is for calibrations. Jake, can you explain to us why it's important that all of the tire pressures are checked before we perform the calibration on the ICC?
Well, Mike, it's just like in collision repair when we're prepping a panel for paint, whether it's a blend panel or a full refinish, we still prep the panel the same way. Same thing in ADAS calibration. You want to prep every vehicle when you do an ADAS calibration. And just a hint, folks, you will be tested on this. Your instructor will check to see if you've documented the tire pressure, the fuel level, removing personal effects, those kinds of things. So get in the habit of prepping that vehicle for calibration and documenting as such. Really critical because you're upsetting the weight in the vehicle. And remember, that radar works on angles or degrees in the front. So, adding a bunch of weight to the vehicle can actually change the degree of the radar in the front.
And we always recommend that you absolutely follow these directions. You notice it does not say place sandbags or center blocks in the trunk. It says fully fill the fuel tank. Now, as we continue on through this intelligent cruise control procedure out of TechInfo, we see that it gives us an outline of the radar alignment procedure. And you'll note that the first bullet point in this section says that a four-wheel vehicle alignment must be performed before proceeding. You notice it doesn't say recommended, it says must. It also says always perform the radar alignment after removing and installing or replacing the ICC sensor. So if for any reason you had to remove that ICC sensor to perform a repair, you must do this calibration process. You also see in the last orange box, it says caution. This system does not operate normally unless the ICC sensor is aligned properly. Jake, any thoughts on this?
Well, you notice that the procedure mentions rear axle, toe alignment, and things like that. We do a lot of four-wheel alignments in the collision repair space. I'd ask you as a shop, how many alignments are you doing in your facility every week? You need to research how to do a four-wheel alignment. and thus you will find that radar and camera alignments are also required when you do a four-wheel alignment.
We're now going to talk about the DCA, or Distance Control Assist. The DCA uses the ICC sensor to detect the distance to the vehicle ahead. If the driver is not applying the accelerator pedal, the system will apply the brakes automatically if the distance becomes too close. If the driver's foot is on the accelerator pedal and the vehicle is approaching the vehicle ahead, the system pushes upwards, yes, you heard me say upwards, on the accelerator pedal to encourage deceleration. Jake, have you ever experienced this in your new Nissan?
I have, and one of the questions I had for Nissan when I went through this training is, well, it just pushed the brakes. Did it turn on the brake lights behind me so the guy behind me doesn't hit me? And it absolutely does. If you feel the vehicle slowing down or engaging the brakes, it absolutely turns on the brake lights in the back.
Now let's talk a little bit about the DCA, or Distance Control Assist, set conditions and cancel conditions. Jake, can you give us an overview on this?
Well, remember, only certain trim levels are going to have DCA in the first place. So you want to make sure you're identifying the vehicle you're working on has it. So some of the set conditions can be found in the navigation screen, and make sure the button is turned on. You also want to make sure the driver assistance switch is turned on. The brake is not depressed and the vehicle is approximately 3 miles per hour or above. When the vehicle ahead is detected, and also when the ICC system is not set.
So great insights. Now let's talk a little bit about the cancel conditions. Like, what are some things that if we do these or this things happen, it'll actually cancel the DCA feature?
Well, it's a great point, and it's a lot like ICC, right? So if there's, a traction control event that has been detected, ABS, snow mode is turned on, or a system malfunction is detected, then it's going to go ahead and cancel DCA.
Okay, great. So again, if I'm driving on the road in winter conditions and all of a sudden I hit a little patch of ice and the traction control kicks in, it's going to turn that feature off.
Correct.
Okay. Let's talk a little bit about when the DCA will not operate. So we talked about, like, there's certain things that have to happen for the DCA, or Distance Control Assist, to work. We talked about, like, there's certain things that happen, it turns it off. But what about when it just won't operate, Jake? Yeah. What are some things we should maybe look for?
Well, the one that's the most common is when the vehicle ahead is not detected. So there's nobody in front of you and it doesn't see that vehicle. It'll actually show you on the instrument cluster that there's not a vehicle detected ahead, and that can cause DCA not to operate. Also, when the ICC system is set, vehicles that it comes to a standstill, there's also the vehicle's brake being depressed. It can cancel it or not make it operate.
Okay. So great insights, Jake. Now remember, all of this information that Jake's sharing, I got to tell you, when I first heard it, I was like, how am I going to remember it? How am I going to remember it? One of the things you got to remember is you don't need to always remember it. You can always go to Tech Info where you can find this exact information. Or another great resource is the owner's manual. Now don't go digging around in the customer's glove box, because remember, through Tech Info, you can view the customer's owner's manual. So Tech Info owner's manual will help you to find what we just shared. PFCW is a system that uses the ICC sensor to alert the driver of a potential collision with the vehicle ahead. In many cases, the system can sense not only the vehicle directly ahead, but also 2 vehicles ahead of it. And if the system detects a potential collision, visual and audible warnings occur. So, Jake, I want to make sure I didn't say this wrong. Not only can it see the vehicle in front of me, but it can see 2 vehicles in front of me.
Well, it's a system really aimed at the potentially aggressive drivers out there, the ones that maybe are tailgating or following too close. And it's just Nissan Infinity's way of monitoring a situation, and if it detects the vehicle ahead or the one ahead of it is stopping abruptly, it warns you either by a chirp or by a light.
Let's talk a little bit more about how the system operates, Jake. Can you share some insights with us? I know that the ICC sensor kind of detects, like, if the vehicle in front of me kind of lowers its speed, but can you walk me through how this kind of works and how it detects it?
Well, mainly it's looking at how close are you to that vehicle, and is a potential collision, could it happen, right? And so it's just warning you that, hey, we notice you're following a little close, and the vehicle in front of you is acting erratically, where it's stopping abruptly, or it's potentially even a turn signal. So those kinds of things, and it's warning the driver of the Nissan Infinity vehicle that, hey, we're detecting a potential collision, and if you don't react, I can even engage the brakes.
So let's just kind of summarize that, right? So the ICC sensor detects sudden deceleration of the vehicle ahead or the vehicle in front of the vehicle ahead. I still can't get over that. And then the system alerts the driver using a warning chime and display in the meter. What do we mean by the meter, Jake?
This is the instrument cluster in front of the steering wheel.
Great. And now this system can only operate if the FEB or the PFCW feature is turned on in vehicle settings, which again, Jake said was in the navigation screen. Again, vehicle speed is also approximately 3 miles an hour or more, and vehicles are detected in the lane ahead. And the ADAS control unit transmits the driver assistance buzzer request via the ITS communication, and the meter display, which Jake said is in the dash, will then request to the combination meter via the CAN. Jake, can you explain that last bullet point to everyone?
Yeah, the easy way to remember that ITS communication and CAN communication is just a communication protocol that the car used to speak to one module to another. So if Mike and I were fluent in two languages and he spoke German and I spoke French, we could send those languages back and forth to each other. And that is exactly what the vehicle is doing internally. It's taking information that it gathers from the ADAS control unit and sending it to the instrument cluster so that the driver actually has a chance to see it.
And that kind of takes us back to that chart you showed a little bit earlier where you had all those boxes. Am I right?
Right.
And keep in mind, ladies and gentlemen, if you really aren't understanding what Jake and I are sharing with you, please feel free to ask your instructor. Now, forward emergency braking, known as FEB. The FEB, or forward emergency braking system, is an intervention system that picks up when the PFCW leaves off. The FEB system uses distance information from the ICC sensor to determine if a collision is likely to occur if braking is not immediately performed. Now, Jake, from what I understand, this forward emergency braking is going to be kind of required and mandatory in 2020. Is that correct?
Yeah, across all trim levels. So even the cheapest trim levels in that vehicle's lineup will have FEB as standard. And remember, PFCW has warned you and alerted you and you've done nothing. Now I'm going to protect, and FEB engages and the forward emergency brakes are applied.
So it kind of goes back to those 3 rings we talked about in the beginning of the class.
Right.
Now, this FEB operation, Jake, can you walk me a little bit through how this whole system works and how it operates?
Well, certainly it's about speed, it's about brake lights, and it's about warning the driver that you haven't responded to the alerts. You haven't responded. I've tried to tell you either beeping or the dash, and now I'm going to engage the brakes for you. And that's what's happening here in the chart.
So, you see, when the system senses that a vehicle is being approached, it kind of gives you this warning, which is like a chime or a warning buzzer, right?
Right.
And then what happens is the accelerate pedal starts pushing upward, and then the brakes apply. But if the system determines that a vehicle may collide with the vehicle ahead, then the system automatically gets kind of aggressive and applies the brakes to bring it to a complete stop.
Yes.
Is that kind of accurate?
Yeah, it's not a gentle stop. So I can tell you that it's not an easy and calm stop. It literally lays on the brakes. We have a forward emergency braking target at Aztec that we've aimed a couple of vehicles at, and I can tell you it's a white knuckle moment when you aim a vehicle at the target and not hit the brakes, and it just comes to an abrupt stop, and it does get your attention.
So Jake, and some of the other ADAS features we've talked about, we've kind of given an overview for the attendees about what the set conditions are, which is like it won't work unless this is taking place, and then also some of the cancel conditions. Can you give me a little bit of an overview of the set and cancel conditions for the FEB?
Well, the big one is that make sure that it's turned on. Remember, certain customers may not want these systems on, so they turn them off.
And again, that's in the navigation unit, right?
Right, it's in nav, and then some of the newer vehicles are actually found in the gauge cluster too.
Okay.
So that's something you want to make sure it's turned on first and foremost. And then you have the speed requirement. In this case, making sure the vehicle is above 3 miles per hour, and also the possibility of a collision of a vehicle ahead. So FEB is one of those systems that you don't want to test. You want to make sure you can understand the set condition, and we can also make it cancel.
Okay, and now let's talk a little bit about the cancel conditions. So when the system determines that the vehicle's coming to a standstill, like it's coming to a complete stop for a stop line, then it's going to disengage. Is that correct?
Right.
Okay, and then also, if a system malfunction occurs, what would be an example of a system malfunction?
Well, system malfunction may be, laser radar is off center. So if we've got, a horizontal or vertical.
So we're in an accident.
In an accident, right? And even if you're working on the vehicle in the rear, you may have it in the front. You may have a pre-existing condition in the front that could affect this, right? The other thing is the one that we see the most is of inclement weather, the system's dirty, that kind of thing.
Gotcha. So remember, if you're ever trying to figure out what the set or cancel conditions are for any ADAS feature or component, you can always find that, again, in Tech Info or in the owner's manual. Now, Jake, what happens if the FEB will not operate? What should we be looking for?
Well, once again, checking to make sure that the vehicle owner has not turned it off.
Yes.
So you got to look in either the nav system or in the instrument cluster to find that, and it's under driver assistance settings. So you want to make sure it's turned on. The vehicle's speed is not detected. So in other words, the vehicle is traveling below 3 miles per hour and it's not detected. So you want to make sure you're meeting that minimum speed requirement.
Okay, great. Shop time. Now we're back to that part which I'm thinking is your favorite part of the entire class, and that is where you get to actually put your hands and work on vehicles. So your instructors now are going to walk you through some activities and explain to you related to the front radar and intelligent cruise control systems. So Jake, any tips you might want to give our students before they go to work on their vehicles?
Make sure you prep them, check those fuel levels, in and out mileage, tire pressure, all those little things. Make sure you prep the car properly.
And also, don't forget, on some of your Sentras, they may have to use that gateway feature, correct?
That's right. Follow the central gateway.
Good luck.